Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from Latent Space. Joining us is Doug O'Loughlin from SemiAnalysis. He presents a case that Microsoft faces structural vulnerabilities despite its AI market position, and that future high-performance computing will rely on recovering obsolete chips due to manufacturing constraints. His framework rejects conventional narratives and focuses on physical limitations that dictate these outcomes. We'll examine his analysis. Doug O'Loughlin from SemiAnalysis challenges two widely accepted assumptions. First, that Microsoft's current AI dominance is secure. Second, that semiconductor supply will continue expanding to meet demand. He contends both assumptions ignore fundamental constraints that guarantee counterintuitive outcomes. He begins by dismantling the permanence of traditional productivity software. The industry assumes tools like Excel and Bloomberg terminals represent permanent infrastructure for financial and business operations. The expectation is that AI will enhance how we use these tools, automating formulas or simplifying navigation. O'Loughlin rejects this entirely. His position: Excel is obsolete. He categorizes Excel as an IDE for humans, an integrated development environment created solely because humans require visual interfaces to manipulate data. When an AI agent can execute data analysis, visualize trends, and run code directly, the visual interface transforms from feature to constraint. He describes a transition where cloud code agents bypass Excel rather than integrate with it. The entire abstraction layer disappears. The conceptual shift here is recognizing that essential software suites are merely human compatibility layers about to be eliminated. These tools exist only because humans need them. Once the human is removed from the workflow, the tool serves no function. This analysis connects directly to his assessment of Microsoft's strategic position. Industry consensus labels Microsoft the king of AI due to its OpenAI partnership and Copilot integration. O'Loughlin presents an inverted interpretation. Microsoft occupies a vulnerable position within a classic innovator's dilemma. He characterizes Microsoft's strategy of licensing OpenAI's models as renting barbarians at the gate. By outsourcing core intelligence capabilities to an external entity, Microsoft is funding the erosion of its own competitive advantage. They are financing the technology that makes their foundational products, Windows, Office, the traditional GUI obsolete. If future workflows operate through agentic systems that bypass human interfaces, Microsoft's monopoly on the human interface becomes a liability rather than an asset. They are subsidizing the force that dismantles their dominance over knowledge work. O'Loughlin then redirects attention to the physical constraints governing AI hardware, where he identifies a structural crisis in memory supply. Industry orthodoxy holds that technology costs decline over time. We expect storage and memory to follow predictable downward price trajectories. O'Loughlin forecasts the reverse. A structural price spike that could double memory costs a 100% increase impacting consumer devices, including the iPhone. The mechanism is a physical trade-off he terms the HBM multiplier. Demand for high bandwidth memory, HBM, used in AI accelerators like NVIDIA's H100S, creates a direct conflict with standard DRAM, production. Manufacturing one wafer of HBM consumes the production capacity equivalent to 3 to 4 wafers of standard DRAM used in phones and personal computers. As manufacturers shift capacity toward HBM to capture higher margins, standard memory supply contracts. He notes that new fabrication facilities have not been constructed in years following a previous market collapse. The outcome: a surprise squeeze. The AI boom is not merely creating new capabilities, it is physically consuming the supply chain for consumer electronics. He forecasts demand destruction, where planned devices cannot be manufactured due to memory unavailability. This scarcity drives a solution that contradicts conventional engineering priorities, the revival of zombie RAM. In an industry focused on the newest, fastest components, O'Loughlin anticipates widespread adoption of CXL, Compute Express Link, technology to aggregate old, discarded DDR4 memory. His reasoning: when capacity becomes the binding constraint, absolute performance becomes secondary. Data centers will pull older, slower memory modules that would normally be retired, combining them into large-scale memory pools to satisfy AI model requirements. The transition is from performance optimization to capacity scavenging. He then addresses the economic and productivity implications that contradict standard linear forecasts. The prevailing assumption is that context windows, the volume of data an AI can process simultaneously, will expand into billions or trillions of tokens. O'Loughlin counters this with the concept of context rationing. Due to the physical memory constraints outlined above, context windows will not expand indefinitely. Instead, we enter an era of vouchers and allocation limits. A model's technical capability to process 1 million tokens does not guarantee the physical infrastructure exists to deliver that capacity to all users. The industry is transitioning from digital abundance to compute metering, where high-quality context becomes a scarce resource distributed to the highest bidders. This scarcity generates unexpected labour market effects. O'Loughlin identifies AI agents as perfectly compliant junior analysts with an effective annual cost of $20,000 to $30,000. The disruption is not that AI assists workers, it is that the junior analyst role, the traditional entry point for white-collar career development, is being eliminated by software. These agents can execute multiple parallel attempts at a problem, iterating faster than any human. The shift is from human single-turn execution, completing a task once and reviewing it, to machine multi-turn execution, an agent completing a task 20 times in parallel and selecting the optimal result. This dismantles the traditional apprenticeship structure in finance. If machines execute grunt work more effectively, how do humans acquire the meta skills necessary to advance to senior positions? O'Loughlin's analytical framework exhibits a consistent pattern. He disregards the social and economic narratives we construct, such as the inevitability of declining technology costs or the permanence of software monopolies, and examines strictly the physical constraints of materials and energy. As long as physical limitations on wafer production and energy persist, he maintains these counterintuitive and often costly outcomes are unavoidable. The question remains, when the cost of your next phone doubles and your spreadsheet software vanishes, will you interpret it as catastrophe or simply physics asserting itself in the new landscape? If you're interested in the video featured in this episode, click the link below to watch the original.